Good day and welcome everybody to our today's second episode of our series ZIEHL-ABEGG Presents. This episode is called Delivering Air Quality for Healthier Buildings. Like you can guess from the title, we are talking about indoor air quality. What is necessary to achieve indoor air quality? What have we learned from the ongoing pandemic? And for sure, we will talk about how indoor air quality and energy efficiency go together. I have the pleasure to have with me here renowned experts who will share their expertise and their knowledge with us today. Let me introduce you to Mr. Kälin Feeney. He's the CEO of VES. It's an UK manufacturer of air handling units. We also have with us Roger Kälin. He's the general manager of the company Lufttechnik in Switzerland, who is an installer for climate technology. Also with us, we have Laura Mansel-Thomas. She's the senior partner of Ingleton Wood, which provides building, design and construction consultancy. Last but not least, we have Günther Mertz. He was the previous general manager for the Climate Building Association here in Germany and currently a senior partner. Welcome. I'm very happy to have all of you with us. My name is Marco Rüttgers. I'm a key account manager for ZIEHL-ABEGG here in Germany, fan and motor manufacturer. Please note that Roger will speak in German and we will translate his answers for your convenience. This is just for your information so that you don't wonder about any delays or any stops in our talks. Well, let us jump in and start with the first question. How do you define indoor air quality? What is your understanding of indoor air quality and its improvement? Günther, let's start with you.
Well, thank you, Marco, for this first question, which is really not an easy one. You know, there are several definitions, several explanations when we talk about indoor air quality. But according to the declaration of our European Roof Association, the EVIA, indoor air quality is for us a term which refers to the indoor air quality within and around the building and the structure, especially as it relates to the health and comfort for the building occupants, that means for the people in the building. And what's also a very important point is IAQ, indoor air quality, is not only something like, let me say, a luxury item. It's really the precondition for health and safety in the building. And so far, in my opinion, indoor air quality, good indoor air quality is a human right. So that's my opinion. And now I look to Kevin. What's your point of view?
Thank you, Günther. So indoor air quality refers to the level of pollutants contained in the air within the indoor environment. Typically, this focuses on specific types of pollutants, but a wider view of air quality should be considered to include temperature and humidity because these are all intrinsically linked. Indoor air quality can be improved by removing the pollutants from the indoor air, but seeing as there are a wide variety of pollutants, the available methods of improvement are vast and varied.
Roger, can these statements be defined more precisely with some numbers?
Well, according to VDI 6022 Room Air Technology, Room Air Quality, the aim is to create healthy breathing air in buildings. This requires a sufficient air exchange rate, low ppm values in the range of 400 to 800 ppm in the room, ideal temperature and humidity of the supplied air, as well as the required filtering of the air according to ISO 16890. As far as SARS-CoV-2 is concerned, this means filtering with H14 greater than or equal to 0.1 micrometers. Low humidity in buildings affects the salt content of aerosols and prolongs viral activity. Humidity thus plays a major role in maintaining the body's immune response and disease defense.
Laura, would you like to add something to these statements from the gentlemen?
I think the other speakers have done a great job of summarising what indoor air quality is. I think it's important to say that good quality air is often when we don't even notice it. It's just there.
Great. Let us come to our next question. What are the main features that influence indoor air quality?
Well, there are several items influencing the indoor air quality. For example, volatile organic compounds, that's the abbreviation is VOCs, moisture, mold spores, dust mites, odors, radon in the lower level of the building, carbon monoxide, and of course, what we are talking here, insufficient ventilation.
What do the others think about the statement?
Yes, I fully agree. Air filtering, air exchange rate, humidity and room temperature in the room climate condition.
Kevin, would you like to add something?
Yes, thanks. I would go further and say indoor air quality is influenced by both internal and external pollutant sources. As Günther says, there are internal pollutants such as biological ones, bacteria and fungi, and also chemical ones, VOCs, CO2 from people. But we should also consider pollution introduced from the external environment too. These are typically natural pollutants such as dust and decay, but of most concern for us all are the man-made pollutants. Such particulate matter could be carbon monoxide, nitrate oxide, sulfur, benzene, etc. from traffic or combustion, power generation, as well as other chemical deposits in the air from building materials, cleaning, sprays and disinfectants. I personally believe temperature and humidity have an effect here too, and while they may not be classified as pollutants as such, they contribute to the environmental conditions which can accelerate the formation of those pollutants.
Yeah, so we have internal and external pollutant sources, as well as temperature and humidity that affect the indoor air quality. And we can improve that with a proper air exchange rate and air filtration. So in other words, we are talking about ventilation. Are there any planned or already existing legal requirements in this regard?
I can start this one. So we have many different indoor air quality standards and guidelines and regulations. These are generally inconsistent or not comprehensive. In the UK, an area we work, for example, is in the education sector. The Department of Education introduced the BB 101 guidelines, which covered ventilation, thermal comfort and indoor air quality for schools. And these standards have set levels of CO2 and thermal deviations by degree days. The ventilation's methods to control this could form mechanical or natural or mixed mode methods, but they have no clear standards for filtration. Therefore, the design decisions fall under the influence of building service professionals. In this example, internal and external contaminants, which, as we discussed, represent the whole indoor air quality, are largely ignored with no set standards for sensing, control or regulation. If we look at another example, the building regulations in the UK, Part F, there currently is no tangible references to indoor air quality. There is legislation pending for this year in October, but this does not entirely address an improvement to indoor air quality, nor does it bring alignment across the different regulation standards and guidance.
Thanks for this insight. So in the absence of regulation and official guidance, Laura, how can designers and building service departments, professionals influence the industry to make improvements to the indoor air quality?
No, I think that's a really good point. And it is important that you need to think about the fact there's a responsibility on engineers. You know, when we become chartered in the UK through the Engineering Council, we personally have a responsibility to do the right thing. And that's regardless of regulations. We can go over and above regulations. We all have that duty specifically to improve the quality of the built environment. And we shouldn't forget that. But as designers, we can also provide better influence through our clients. So through informing the clients and the project stakeholders much more proactively about the real benefits of improved indoor air quality. An example, to come back to what Kevin was saying around schools and universities, better indoor air quality leads to improved cognitive function, improved educational performance, and obviously that later translates into improved reputation and standing for the school in terms of results. It's win-win. And you could say the same thing about commercial environments, of course, where good ventilation design leads to very marked improvements in worker productivity, improved wellness, and then, of course, less downtime due to illness. You can't argue with that.
So we see that in the UK, at least, there have been the first approaches. Even yet, there have not been real standardized regulations. Roger, how is the situation in Switzerland?
Well, new guidelines for filtering are planned for the medium term, according to the Lucerne University. Basically, however, the existing guidelines apply according to the SIA, Swiss Association of Engineers and Architects.
Well versed in the European Union standards. Do we have any legal requirements on the complete EU level?
Unfortunately not. That's really a pity. And we want that indoor air quality has to play a more important role in the new version of the Energy Performance of Building Directive, the EPBD, coming from EU. And there we need more impact concerning the indoor air quality. The goal must be that the indoor air quality level in a building is shown, really clearly shown, on the energy or on the building certificate.
Let's go to the practical side. How does your understanding of indoor air quality affect the equipment choice and maintenance? For example, cleaning of mechanical ventilation, filters, heat exchangers, UV filters, or even carbon filters?
Well, to realize appropriate EAQ levels, we need, concerning the ventilation, quite easy formal, the right amount at the right time at the right place. So that's the formula. Therefore, we need high efficient components. We need fulfilling of the already mentioned VID 6022 requirements, and we need regular hygienic inspections, ideally based on legal requirements.
Vorgaben. Well, the cleanliness of ventilation systems is a basic requirement, especially when it comes to hygiene. In the case of air recirculation systems, special attention must be paid to the filter quality of the recirculation air. UV filters or H14 filters are capable of filtering or disinfecting SARS-CoV-2 viruses. Regular hygiene inspections with a swab test are prerequisite. The type of system determines the type of maintenance required.
Yes, but we must remember that this is all customer driven. As mechanical ventilators, manufacturers, we have always been proponents of supplying fresh air and removing exhaust air from the space, with the addition of filtration to remove certain levels of external pollutants before they enter the building. Building requirements in indoor environment cannot be addressed by one single solution. There are many factors which contribute to the system, including the choice of ventilation strategy, but also the type of filtration and energy recovery technology to meet the demands of the application. The demands, in addition to performance specification, could also be as a result of space or cost drivers. Filtration requirements at the moment, or indoor requirements at the moment, are often minimal in terms of the available technology and filtration effectiveness that we have available to us. Or if they're higher level, they result from the preferences of the building service professionals, but they can also be driven by knowledgeable indoor air quality aware end users.
End users, and I understand all the positions around technology and the options we have available to us. I do think that we have to consider the human factor in all of this. My preference is always for simpler systems. They're easier to maintain, and they also survive the handovers between staff over the years that they're installed. So I would say that anything more than basic filtration should really be the last resort rather than the starting point.
Laura, I got your point. Let's dig a bit further. How does COVID change the way we think about indoor air quality?
I think it's a good question, and as building professionals, COVID has made us realise just how poor the air quality in probably the majority of our public and private buildings actually is. And more to the point, it's made the general public aware of how important that indoor environment and that air quality really is. Air quality was a big political issue already in UK cities, particularly in London, but the focus was very much on outdoor air pollution, not indoor. Indoor was safe, and issues such as vehicle exhausts and fires, open fires in houses. So there's been probably an understandably knee-jerk response to this, with high-tech solutions such as UV treatment and HEPA filtration seen as the answer to everything. But I think my opinion is that we should absolutely look at bringing all our internal spaces up to an acceptable level. I think all of us agree on that. That level might be building regulations, it might be BCO, British Council of Offices standards, it might be BB 101 for schools, which Kevin was talking about. But that we should just urge a bit of caution about going too much further. There's a huge amount of work to do just to bring existing buildings up to scratch. For example, in the UK, over half of our hospitals were built before even the basic building regulations existed, and that's really important. I think the one other thing that I wanted to say on this was that the very new research from the UK Aerosol Research Centre suggests that the COVID virus actually loses a huge amount, perhaps up to 90% of its ability to infect within 20 minutes in the air. And that really does re-emphasise the importance of short-range COVID transmission, with physical distancing and mask wearing actually likely to be the most effective means of preventing future infection. So ventilation, though still absolutely worthwhile and very important, is likely to have perhaps a slightly lesser impact than we had at first thought. And this is all supported by the epidemiological findings that we see on the ground.
Okay. Kevin, what is your take from a manufacturer's point of view like VES?
So from a manufacturing ventilation background, we have seen customers' drivers change as a result of constraints placed on them through by COVID, through wearing face masks and house isolations, etc. So COVID has generated a thirst for understanding and the prevention of the spread of disease to ensure that our health service in the UK is not overwhelmed, but to also enable us to carry on doing those activities and living the lives that we want without these restrictions in place. So for me, COVID has made what was invisible visible, and importantly is giving those supporters and experts in the field of indoor air quality a great platform to increase everyone's knowledge and awareness and desire for better indoor air quality. This has a direct relationship for people in terms of not getting ill, but also being able to get back to normal life. So for all of us as occupiers, end users, building owners or companies, we have a new demand and enthusiasm for indoor air quality.
That's good. Roger, what about you? How do you see this?
Well, the main point here is the requirement of air quality in the room in terms of air filtration and room humidity. This requires above all the conception, planning and execution or retrofitting of full air conditioning systems with humidification and disinfection to improve the immune response. So this means it's health of the employees and comfort versus the investment in high quality ventilation and air conditioning systems.
Well, I fully agree, Roger. COVID demonstrates very clearly and obviously the high importance of ventilation, appropriate ventilation rate, and indoor air quality. Nowadays, I'm deeply convinced everybody knows that mechanical ventilation is on a high level able to reduce the risk of infections dramatically, especially in school buildings. We saw what's happening when we try to ventilate via windows. In wintertime, pupils were sitting with coats and hats and scarves and clothes in the classrooms. That cannot be the solution. one result was that we talked a lot of the air room cleaners. This was a high discussion, especially for school buildings and classrooms. Well, no doubt the very good air room cleaners are able, when they are equipped with the HEPA filters or UV disinfections, then they are able to reduce the virus load in the room, and so they are able to reduce the infection risk. But that's it. They are not able to reduce the CO2 level. They are not able to provide fresh air in the room. And at the end, they cannot be an alternative to mechanical ventilating system.
Thank you for all your insight. Really appreciate it. Let's circle back to the ongoing pandemic. What have we learned from COVID?
We have the right to good air as a health prevention. Good air, in the sense of air quality required to fight SARS-CoV-2 viruses, should be a standard for ventilation and air conditioning systems.
Yes, absolutely. I'd also add to that, Roger, that the public has learnt that our buildings aren't the safe havens that they thought they once were. The well-being and wellness agenda was already starting to address this, but it's being brought very, very quickly into the mainstream by COVID, but also by a changing public mindset around health, diet, climate change, and so on. And as engineers, we need to look really carefully at some of these wellbeing standards and think about how they relate to building services. And we need to use our engineering skills, perhaps, to pull out the facts from the fiction and the essentials in there from the nice to have.
Yeah, and if I go on from Laura, I think the only really agreed learnings are that fresh air is the best solution to reduce the spread of disease, protecting indoor environments and getting us back to normal. We have also learned that there is no one single optimal method, as applications are different. So the only single agreed guidance is that increase in fresh air rate and therefore ventilation rates to the indoor environment. I feel like we have also learned energy has taken a backseat to health and safety from the severity of the pandemic and the concerns around fresh air rates and recirculated air. Air volumes have been increased to maximum levels or arbitrary levels, and as a result this could be increasing heating and cooling demands while stopping those energy recovery devices where there was a potential for cross-contaminated air. So we have learned, as it should be, health and safety trumps cost, but what we haven't learned yet is for how long and when that tipping point will occur.
Well, I want to add that there might be differences on what is the optimal method. But we definitely saw the limited effects of ventilating via windows. We learned that IAQ means safety, and we learned that only high-efficient ventilating systems are able to guarantee both indoor air quality and energy efficiency.
I agree. Let us look again at this from a practical point of view. I mean, in your opinion, what is the role of sensors and controllers when managing situations like that?
Well, I'm happy to start this one going. I think sensors are incredibly important, but we do need to understand and think about just what it is that we're monitoring. Is it carbon dioxide? Is it particulates? Is it NOx levels? And then what are we going to do with those results? So there's been a jump towards carbon dioxide monitoring, which is great. It's a good base level way of understanding a room. But without a way to then improve air change rates, for example, that data becomes quite worthless. And the quantity and the location of this equipment is equally important. So in the UK, we see the government response, which has been to provide a single CO2 monitor to each classroom, which is great. But the placement of one monitor might be somewhere near the teacher, so there's ease of access. It might be near a window or a ventilation outlet away from easy tampering by students. And it's easy then to see how this could give reassuringly low levels in terms of carbon dioxide, whilst actually there might be stagnant air pockets at the back of a classroom, away from windows, or in the centre of a densely occupied zone with a lot of students in there. The opposite could be true. The situation might be much better than the readings tell us.
That's a valid argument, Laura. Kevin, would you agree to this?
I don't think there is a right and unified indoor air quality strategy to deploy across the board. So it's important that decisions are made to meet the applications and the drivers of the indoor customer. So sensor and monitoring and controls allow these decisions to be made to meet the drivers in these complex and variable situations. Indoor environments for me are like mini ecosystems, which can change dramatically with occupancy levels and different activities in the building, but also possibly from what's going on outside. So sensors and control allow measurement of the variables and can help us make adjustments to meet these objectives or specifications, and balancing the need for indoor air quality and energy consumption. For example, why would we want high indoor air quality at the expense of energy when there is no one in the indoor environment? If we don't get this sense of control and strategy into the system and only deploy fixed thinking and fixed controls, then I don't see how anyone can be satisfied with the environment. And the fear I have is that the importance of indoor air quality will lose traction and focus as other priorities like energy and cost of energy with some tangible feedback are more easily understood and addressed. I think sensor and control also allow us to continue that visibility of indoor air quality. And if we take the sense of any other performance indicator in a business, what doesn't get measured, doesn't get managed, can also be applied here. So COVID restrictions has made indoor air quality visible, but it will change. And as we can have to live with COVID, so we will lose this visibility, and other tangible feedback of, say, financial costs of energy will take the priority. And with no indoor air quality data, other than anecdotal, indoor air quality will suffer. If we continue the example about business performance, and look at visuals as a good example, using sensors and controls with visible feedback, dashboards and reporting not only provides better controls decisions automatically, but it could also engage end users to change and adapt, and it keeps the data at the forefront and allows these goals and objectives to be set and reported against. Keeping indoor air quality visible provides the best chance of managing it, and in the future help us balance between indoor air quality and other priorities like energy.
So Kevin, you mentioned we need to balance between the need of indoor air quality and energy consumption. Let us start with Roger. In your opinion, is there a conflict between energy consumption, efficiency, and indoor air quality?
Not at all. Health is the highest good. Existing systems can be adapted with retrofit renovations and optimization in the air exchange rates, or with retrofitting of humidification and UV disinfection. The energy savings gained make these energy neutral when the air volumes are increased in operation. How do you see it, Günther?
Well, of course, you're right. A high level in the indoor air quality requires, of course, more energy. But with our innovative air conditioning and ventilating systems, we are, I'm deeply convinced, able to fulfill both requirements. Inefficient ventilation systems or window ventilation do not only cause poor indoor air quality, they have also negative consequences in economical points of use. The very well-known Promoting Action for Healthy Indoor Air project calculated that in the EU every year 2 million healthy hours are lost due to the poor indoor air quality. This not only means a loss of productivity, it also places a heavy burden on our health care systems. And that's the problem.
So we have a side here who clearly sees indoor air quality means health. Do you still see a conflict, Kevin? And because energy investment is worth it, according to your other statements?
Yes, undoubtedly If the premise is to improve indoor air quality is around ensuring fresh air in terms of reduction of pollutants and contaminants, then we need to use the outside air, which is generally fresher, with the need to filter that to remove some of the outdoor pollutants. We also need to remove the indoor air, which is no longer fresh. These activities require some form of energy. Of course, I feel we can use sensors and controls and technology to create smarter strategies that adapt to the constantly changing environment. This will allow us to have a better chance of creating great indoor air quality whilst balancing the energy cost conflict.
Understood. What about you, Laura? Do you think there's a conflict?
I guess I don't think there needs to be a conflict, and I would say there probably is, though, if we go too far. We need to focus, and I said this before, on controlling pollution at the source. So whether that's a virus controlled through testing, not going into the office if you've tested positive, mask wearing, or if it's vehicle exhaust. So there's been some great developments, and this is potentially solved by the move towards low emission zones and longer term electric vehicles. Rather than trying to treat the symptom, we need to treat the cause. And by doing so, we can really ensure that energy saving is the top priority and doesn't need to conflict with improved indoor air quality.
Okay, Laura, let's go to your expertise. In your opinion, which is more important, energy saving or indoor air quality when planning buildings in the future?
So when planning buildings in the future, it's a slightly different question to solving the problems that we have today. And I would say that energy saving has to be the top priority. We're in a climate crisis. Carbon emissions are currently obviously the big problem. But as our electrical grids decarbonise, they will become less of a direct issue, and we'll have to start, or perhaps this is returned to, focusing on energy and energy efficiency. Part of this, we also need to make sure that when we bring that air into a space, that the air distribution and the movement within the space is efficient and effective. Otherwise, sensors might tell us we're hitting targets, but that would be undone by poor air distribution design. What are your thoughts, Günther?
Well, indoor air quality and, and ventilation are the key elements when we talk about zero energy buildings. When designing a building, both criteria has to be considered. It's for me not a question or, it's a question and. We need both, and we are able to do that. We need energy efficiency and indoor air quality in buildings, there is no doubt. And with our innovative system, components and the back systems, I'm deeply convinced we can do that. I remember very well some years ago, we had in Germany and many other European countries hard and emotional discussions about the so-called sick building syndrome. What was behind that? People, especially in office buildings, became sick. We talked about the Monday fever because many people became sick on Monday morning when they came to the office. A lot of experts and even doctors said the air conditioning and the ventilating system is the reason for these symptoms. But the fact was that due to the energy-saving reasons in many, many buildings, the air exchange rate was extremely reduced, and the result was that these buildings were indeed sick buildings. But not the ventilating system itself was the reason, but the running of the entire system. But I hope nowadays we have more skill about these correlations.
So we do see a connection between indoor air quality and building design. Let us dig a bit deeper. How will indoor air quality affect the technology and building design?
I think we do need to be careful not to over-design. I think that's really the very important thing. We've learned a lot about design, about careful approaches to design, because over-design results in higher energy demand as we perhaps increase pressure drops, airflow rates, fan power more than we really need to. I hope we'll think about the sources of pollution, again, keeping COVID out of the office rather than HEPA filters once it gets there, as well as the solutions. I think we're probably all saying different versions of the same thing here, which is it's a holistic approach, I guess, to building design, thinking about technology, well-being, and real sustainability in the built environment. And that means buildings that work for rather than against the people that occupy them, and buildings that are intuitive and easily and readily understood. We've got an example, I guess, of something like this with classroom design. Coming back to BB 101 again and schools. With cross-flow ventilation. So we had a nice system with clerestory windows and low-level windows, so high and low level, nice level of ventilation. It was starting to become a standard way of designing a classroom, until much tighter and tighter budgets pushed us back towards single-sided ventilation of classrooms. We all knew that was the wrong design solution. We all knew that the air quality would be worse. And then we need complex controls, complex systems to correct what actually was just a poor initial design solution.
Thanks, Laura. Roger, as an installer, would you like to add something to this statement?
Well, in the long term, the trend will certainly be towards full air conditioning systems with high-quality filtration and process reliability in the sense of redundancy of ventilation and air conditioning systems. In further consequence, we have the right to healthy air today, tomorrow, and the day after tomorrow. Let's get started.
So, we are coming to an end of our discussions, and first of all, I would like to thank all of you for your input and insight. I received the information from our studio that we have further questions arrived from the audience. So maybe we can just jump on these questions and try to answer them. So the first question we have received is, we have been told that opening windows is sufficient from COVID, but we are hearing now that this may not be enough. What more should we be doing? Laura, perhaps you have some thoughts about that.
I guess I do. I think at the start of the pandemic, there wasn't much else we could do. We knew we needed to improve ventilation. The easiest way to do that, open the windows. And it certainly didn't do any harm, and in lots of cases it will have helped. But we know more now. We can be cleverer with our solutions, and we can make them bespoke to the rooms, the classrooms, the spaces. And I think we've moved on from that initial thought. Natural ventilation and windows might be the right solution, but not always.
Okay.
A little bit, if that's okay.
For sure.
I agree with Laura that we've discussed that sometimes these applications are suitable and sometimes not. And if we look at just placing equipment with recirculation filters and UV and shutting all the windows, that's not correct either. So it is difficult, and every solution is different. So we need to talk to more experts and bring people involved to make sure that you get in the balance between ventilation as required, and also if you're controlling the virus, you're doing in that sort of way. So looking at different options for the right application.
Thanks, Kevin. I hope this answered your question. Let us jump to the next one. Another question. In practical terms, as consumers, can we really find a fair balance between energy use, air quality, and equipment costs? Günther, maybe this is a question to you, which you can try to answer.
Well, all over Germany and other countries, we have very, very good best practice examples, buildings, high-rise buildings, where both requirements are fulfilled. We have, as I already mentioned, or as we mentioned, we have the technologies to do that. We have now the requirements concerning energy saving. We have high, very efficient heat recovery systems. So for me, it's no doubt, and it's clear, and we have lot of examples that we can realize both aspects.
Thanks. Okay, we have a further question. Does the move to flexible and hybrid working change the way we approach this problem with less people in our offices? Do we need to rethink the ventilation rates? Maybe, Kevin, I think this could be a good question for you.
Okay, so I think it presents an opportunity. We already have different occupancy levels in different industries and environments, and this is just an extension of that. In office spaces we could have a variety of occupancy levels. So if we don't look at that and include that within our strategy and balance indoor air quality and energy, we could have a problem. Either we're over ventilating with no one in there and spending lots of energy, or conversely, if we don't understand what the level of occupancy is and we don't track that and monitor it, we could be underventilating in certain areas. So I do think it provides more of an opportunity, but we do, as Laura said and we have said, looking holistically and looking at things and adding it up and making sure the right decisions are made is important. But certainly I think it's an opportunity to find that balance.
I think this is a good approach, and I hope this answered your question. So, Roger, our audience has a question for you. What do you mean with the right to have good air?
Well, the right to good air, to me, is a question of protecting our health. The buildings we build today are optimized in terms of energy. They are like preserving jars. They are very, very airtight, so nothing gets in and nothing can come out. So the buildings before, we had windows for ventilation, and the ventilation was pretty good. But with those tight buildings, nothing can get in and nothing comes out of the buildings. So we need to get air in the buildings, filtered air, in order to make sure that we protect our health. For the existing buildings, we can retrofit them with good filters, and we save 30 to 50% of energy and operating costs as well as CO2. So let's get started.
Thank you, Roger, and thanks for the answer. We have another question. During this pandemic, ventilation is very important. But if we increase outdoor air, load on system increase, and system is not designed for higher load, what is recommended in such case? Günther, can you answer this?
Well, I think retrofit and the optimization of the entire system is the only thing you can do in this case. And our ministry opened a subsidy program to finance these optimizations of existing systems. And that's the only thing you can do, of course.
Thanks, Günther. I get the information from the studio that we are running out of time, but don't worry. The further questions which you made, we will answer them via email. Again, I thank you very much. It's really an honor to have experts like you with us. And I hope the audience enjoyed this discussion as much as I did. So, all in all, I would like to thank you for the participation. And please check out our landing page. We are posting this event later, shortly, on our landing page. If you have any further questions, don't hesitate to contact us anytime. So that's it from our side. Stay safe. Thank you.